All right. Thanks, folks, for joining. We're excited to uh, go through a bit of a background on Rockset migrations and DynamoDB ETL more generally. Um, I'm joined by my colleague Alex here,
Hi everyone.
and maybe we'll start with just some more formal introductions. So I'm Paul Dudley. I'm the co-founder and CEO of StreamCap.
I'm Alex. I'm a solution architect with StreamCap, and I will give you more technical details about DynamoDB and the pipelines towards Rockset alternatives.
Great, thank you. So the sort of beginning of this journey that we'll be talking about today was very much, set off by the Rockset side of things when earlier this year they announced that they're going to be acquired by OpenAI. That's great for the Rockset team, and I think an important capability for OpenAI. But as a part of that acquisition and integration, the standalone service of Rockset is being shut down, and so that definitely introduced some very meaningful challenges for Rockset customers. Typically, folks are not in a position where they have to migrate databases in a very short period of time, but for those folks who are on monthly plans with Rockset, they had to migrate by September 30th. Folks who are on annual plans had a little bit longer, but generally needed to migrate by the end of the year. And so you had a lot of folks who were kind of looking for solutions to that migration and wanting to do it urgently. So Rockset, a bit of background, it was founded by some of the folks who created RocksDB at Facebook. And one of the things that's been very clear in talking to a bunch of Rockset customers is it's quite unique in terms of the value proposition that it offered. It has a document database structure and native ETL capabilities for MongoDB and DynamoDB. And that meant that folks who were using it had a really tight coupling between those two different database systems, and were really relying heavily on that capability to ultimately generally power sort of more real-time analytics. There's actually a pretty diverse set of use cases that Rockset supported downstream. Like I say, generally analytics, but also search, and they had a very unique approach to indexing. I think they called it converged index, which allowed for indexing by columnar, row, and search-based indexes, which give a lot of flexibility in terms of different use cases you could use it for. So there was really a unique set of circumstances that this put us in, where Rockset was very unique in terms of its value proposition, and people had to migrate off quickly, and so they're kind of scrambling for how do we meet all these diverse requirements. So as I said, if you're on a monthly plan, migrating in about a month and a half here, very tight timeline for database migration, and then you're solving for a number of kind of diverse sets of problems, because if you start to look at the common alternatives, we've seen ClickHouse most regularly, but also folks looking at SingleStore and TinyBird and Postgres, Snowflake, Elasticsearch for the different use cases. This partly comes back to the different capabilities that Rockset offered. So for real-time analytics, ClickHouse and SingleStore and TinyBird are all well suited for that. TinyBird's built on ClickHouse, so some very similar underpinnings for sort of more traditional data warehouse type use cases. Snowflake, obviously. Some folks that we've talked to are using Postgres for kind of list building, things like that. Others moving back to Elasticsearch for search use cases. So because of that diverse set of downstream use cases that Rockset offered, we led to a number of different options being considered. But as I say, most frequently we're seeing folks choose a sort of more SQL-oriented, low latency analytics like ClickHouse, SingleStore, or TinyBird. And this kind of had some challenges that folks had to face, because for ClickHouse and SingleStore, they're SQL oriented. They're expecting a more structured data, whereas the data coming out of MongoDB and DynamoDB are semi-structured and more flexible data sets that that Rockset handled very easily natively, but that these other databases do not. And so this, and then a final challenge is that a lot of folks on Rockset were using DynamoDB as their source database, and there really aren't good commercial solutions out there for ETL to get the data out of DynamoDB. So I had this challenging combination of things of hard to get data out of your source database in the absence of Rockset, and then your new destination databases not natively supporting that document data structure nearly as well as Rockset did. So we'll hand over to Alex here to go through a little bit more detail on some of these elements.
Yeah, so the first obvious idea is to get that data out of the source databases. DynamoDB, like Paul said, is particularly challenging because there are not a lot of good options out there. So let's talk a bit about the technology that could be used to stream data and also backfill initial data from DynamoDB. So there is the Streams API, which can be used to get to CDC, change data capture, out of DynamoDB. A challenge with this one is that the retention is only 24 hours. There is an option, obviously, to use Kinesis for getting longer-term persistence of the change stream. However, this is another piece of technology to add to the mix, and also cost, right? Because it incurs extra cost. So for StreamCap, the connector uses the Streams API directly, and handling the persistence over 24-hour window is through internal Kafka that is managed by StreamCap. For the backfill options, we have the Scans API, which was originally supported by StreamCap connector also, but this one also raises the problem of cost, right? Because it needs read capacity units and it incurs extra cost, while the S3 export generally is much more equipped to handle large tables, and it doesn't incur extra cost for getting that data out of the initial backfill snapshot data out of the DynamoDB table. For the data structure, it's very similar to Mongo in terms of the flexibility of the structure of the data. So we stream it as JSON, similar to how we do Mongo internally through Kafka, because trying to fit it into an Avro protobuf type of strong structured schema format would not make much sense. Next slide, please. So now that we have the source connectors, DynamoDB, MongoDB, or other connectors, we can obviously think about sending this data to a destination. So we have the source connector, the destination connectors, and the pipelines that link all this together. So pipelines can be used to send source topics to a certain destination. It links source to destination, or it can be used in addition to send transform topics. So apply some in-stream transformations and send those transform topics to a destination. Data from a source can be sent to multiple destinations. It can be transformed in various ways and also sent to multiple destinations. So generally speaking, the two major problems that we need to solve for sending, for example, DynamoDB data to ClickHouse data are data consistency and fitting those semi-structured and loose, let's say, data models from Dynamo to a more structured database like ClickHouse, and also transformations that maybe Rockset used to have, and you need to migrate to the new data pipeline. So with the combination of built-in capabilities of the StreamCap platform and custom transforms that we can engineer together with our customers, we've been able to solve all the use cases that we've seen so far. Let's go to the next slide. So I was mentioning the challenging of fitting semi-structured data into a more structured type of database like ClickHouse, Postgres, Single Store. Paul was also mentioning that there are many alternatives that are trying to compete for the Rockset use cases, and we've seen also customers that need more than one destination to cover all their use cases, right? So they chose, for example, Postgres to do some user-defined filtering and querying and list building that Rockset was able to do, and ClickHouse for the real-time analytic OLAP types of queries. So we've supported this transition. Obviously, StreamCap is very well positioned to get this data from the source and stream it to multiple destinations in case you have this kind of polyglot persistence that you want to use to replace all that Rockset managed to do. So it's very easy to stream the data to both ClickHouse and Postgres, for example, the same data, or the source data plus transformed data. So we've been helping customers migrate Rockset transformations, but also apply various ad hoc transformations that are required to be able to fit the source data into Postgres, for example, which is even stronger typed and less forgiving than ClickHouse with semi-structured data. Next slide, please. So let's go again through the services and solutions that we can provide. So data transformations, I think it's it's important to mention it first, right? Because like I said, Rockset had these ingest transformations, SQL and JavaScript, that many customers would use to do various things with the data before persisting it. So first of all, in order to have the same functionality as before the migration, those transformations need to be migrated, but also because the destinations are not behaving exactly like Rockset, there are some additional transformations that we need to apply in order to be able to finalize the data pipelines and satisfy the use cases. So data types are a challenge, like mentioned, especially for SQL strong type databases. So we have the StreamCap transformations are based on Flink for in-stream transformations, but we have a lot of single message transforms, single record transformations, we could call them, that can be applied on the source and also on the destination connectors themselves to be able to quickly and very efficiently account for any discrepancy on data type. And I'm going to mention here a few, for example, dates. Sometimes in MongoDB and DynamoDB, they are sometimes they come as numbers of milliseconds in epoch time. They come as ISO formatted date strings. They come as a millisecond epoch timestamp, but as a string data type and not as a number data type. So all of these have to be managed so the data can be ingested in a consistent way. Unnesting is another very often use case that we see very often. So you have nested arrays and you would like those nested arrays to become standalone records in the destination database. So this is easily done and we've seen this very often. So next slide, please. Streaming transformations. Like mentioned, StreamCap is based on Flink for doing in-stream transformations. many of the JavaScript transformations that Rockset users were having can be translated to plain SQL functions, right? They are usually very simple things like if you have, for example, more phone numbers or more addresses, like in a user entity, let's say you want to get the primary one, or things like that that are pretty simple to implement with normal SQL functions. So they are not necessarily mapped one-to-one as they were working in Rockset, but there are other JavaScript transformations in Rockset that are more complex. There are full-blown TypeScript projects that need to be run as such, and we run the same or with little modifications if possible, the JavaScript on the JVM and on Fling. So until now, we didn't see any kind of big challenge with moving transformations. We were usually able to migrate them pretty fast, generally speaking, we can say we can match the Rockset capabilities for ingest transforms. Next slide, please.
Great. Thanks, Alex. Yeah, well, I mean, I think you covered the transformation migration piece there. I think one other aspect that this has been important for folks who are doing this they've got other work to do associated with these migrations if they're moving off of Rockset. So, some of that engineering work, just comes to our team to help make sure, or at least your team doesn't have to do it because we've already done it. And ultimately helping folks kind of meet the tight deadlines associated with that migration. But also generally, if you've got DynamoDB data, even if it's not associated with the Rockset migration, I think it's just as applicable there. So just a little bit about our approach. So we offer both a cloud offering and a bring your own cloud. We've seen some folks want the simplicity of not managing anything in their cloud, and others have considerations around data residency and data privacy where it's preferable to keep the data plane in their environment, and both of those are options that we offer. We're a global team, and so we've got follow the sun 24/7 support and 4 nines uptime guarantee. So ultimately we're helping folks to transition their ETL workloads and support low latency replication from Dynamo and MongoDB and a bunch of other sources into a variety of destinations. So we've been talking a lot about real-time, ClickHouse, single store, what have you, but we also support Snowflake and Databricks and BigQuery, Postgres, and a bunch of others, which won't go through everything, but it's all available on our website. So that's a little bit about us. If you want to learn more, feel free to reach out to me. I'm at paul@streamcap.com, and we also have a free trial, so you can just go to the website, streamcap.com, and you can go set it up and set up a pipeline and get it going. And our team is there to help if you have any questions. And then, I think what we'll do is jump into some of the questions from the viewers here. First one, Alex, I'm going to let you take this one. Are there any limitations on the number of source tables?
No. As long as we have not set a hard limit in the documentation, but we have seen multi-tenant use cases implemented with the table per tenant architecture, so to call it. So we have successfully handled hundreds of tables per source connector. So I would say as long as it's not many thousands, it should be fine. So let's say a few thousands would be the overall limit, because if you have many thousands, then it becomes let's say, prohibitive on the number of on the CPU and memory and the resources, right? You have to rethink the multi-tenancy or the use case why you need so many thousands and thousands of tables, right? Because there might be a much more efficient way of implementing it with regards to cost, right? Because virtually being cloud, we are unlimited. We can create how many source connectors we want and handle all those tens of thousands of tables. But it would not be the most efficient architecture.
Yeah, I think we've mostly seen that with large single tenancy deployments where there are a lot of, on the source side, a lot of, maybe you have dozens of tables, but across, maybe hundreds or thousands of dedicated customer environments. Yeah, so. Okay, great. And then another question here about what destinations we support. I guess partially maybe answered that on just the last slide there, but I guess to broadly think about it in a couple of ways. So one is you have real-time databases. So that's things like ClickHouse and Single Store. We also can expose the underlying Kafka that we use. And there's a number of systems that can read from that. So things like StarTree or Materialize, Tinybird can just treat our Kafka like any generic Kafka essentially. And then we do a lot with the more traditional data warehouses and data lakes. So Snowflake, BigQuery, Databricks, S3. And then we also see a fair few folks writing back to SQL databases like Postgres, MySQL, SQL Server, and others. So that's not an exhaustive list, but gives you a sense of the different types of destinations we support. Now we have another question about pricing. It's relatively simple. It's based on the usage, so the amount of data that we're processing. In gigabytes is the primary metric, and then compute for transformations. There's a pricing page on the website, and then if you have any questions, if you want to bring your own cloud, that's more of a conversation. But again, based on usage fundamentally. And then somebody else asked about using Kafka. So I mentioned we can expose our Kafka to be read from. You can also write to our Kafka. So we're seeing that more and more with folks where they generally start with us as a way to easily get up an ETL pipeline from a database to another database, but then they have other use cases for event data that they either want to read that data from ours or write to it, and we can support that as well. Yeah, it's regular old Kafka, so it's going to work for anything that Kafka would. And then a question about what regions that we support. So for the cloud offering, for bring your own cloud that can be deployed in any Azure or AWS cloud environment, we probably support Google as well, but that's sort of coming soon. So if you're on Google, just reach out to us. And then for cloud, it's on AWS, but we've got support for US East and West, as well as Ireland in Europe. So yeah, it's pretty easy for us to spin up new regions as well. So if it's interesting, reach out to us if we don't have coverage for your region yet today. Yeah, so I think that's the main things we've got. And yeah, again, appreciate you all taking the time to join us today. And if you're interested in DynamoDB or MongoDB or any other streaming ETL, feel free to get in touch. And or if you just generally have questions, we're always happy to chat with folks about what they're trying to achieve and help out. So thanks again, and thanks Alex for digging into the technical details with us as well.
Thank you everyone for your time.
Great. Bye.
Bye.